Good afternoon. My name is Alka Singh, and today I'm going to give the presentation on structural elucidation of an unknown organic compound. So first we will start with this slide. So in this slide, we will discuss about the IR spectrum of the unknown compound, in which we will discuss how we will identify the functional group, and then we will do the assessment of the degree of the unsaturations, then absence of peak, how we can figure it out, and the fingerprint region analysis. And beside of that, we'll discuss the combining IR with other spectroscopy data. So for this, we will go to the next slide. So as I discussed the first topic, the point is identification of the functional group, where we have to see the different functional group absorb IR radiation at specific characteristics frequencies. For example, a broad peak around 3200 to 3550 centimeters suggests one OH group, which is alcohol or phenol, while a spark peak at 24 2 to 49 centimeter indicate a nitrate, which is C triple bond and group. The second is assessment of the degrees of the unsaturation. So the presence of the peak in the C triple double bond C stretches the region which is 1620 to 1680, or C triple bond C stretch region can indicate the presence of the double or triple bonds contributing to the degree of the unsaturations in the molecule. The next is how we'll check the absence of peak. So the lack of the certain peaks can be suggest as informative as their presence. For instance, the absence of the strong peak around 1650 to 1750 suggests there are no carbonyl group in the molecule, and the absence of the broad peak around 320-350 indicate the no OH or NH groups. So the next we will discuss the fingerprint region analysis, that is 1500 to 400 centimeter. This region contains many unique bending and the stretching vibrations that are specific to individual molecules. While complex, it helps confirm the identity of a compounds by matching it with known spectra. So the last we discussed about the combining, how we combine IR with the other spectroscopy data. So IR spectroscopy is most powerful when we used a conjugation with the other spectroscopy techniques such as NMR and the mass spectrometry. This combined approach allows for a more comprehensive and accurate determination of a molecule structure, as each technique provide complementary information. And okay, so in the next one, we will discuss about the mass spectrum of the unknown compound. Again, as we discussed about the previous slide, we will discuss about this slide also. So in this, we will have to first check the molecular ion peak, which will identification of the peak of mass to charge, which is 150 to 152. The molecular ion peak for 4-bromo-butanil, butane nitrile will appear as a pair of the peak due to the presence of the bromine. The peak with the will be at 150 to 152, reflecting the 79 bromine and 8 bromine isotopes with the 1:1 intensity ratio. The second is the isotopic patterns. A significant fragment peak at 71 corresponding to the loss of the bromine atom, which is 79 or 81, indicating the remaining three carbon chain with the nitrile group. And the third one is the fragmentation pattern, the formation of the C3H5N positive, a peak at 55 due to the further fragmentation of a carbon chain and the nitrile group. And the fourth one is the base peak analysis, how we can analyze the base peaks. That is the most intense peak, or the base peak might be we'll say 41, representing a stable fragment such as the propenyl cation, that is the three carbon 3 and the 5 hydrogen positive, which is a common in alkyne nitrile compounds. And the fifth point is how we will determine of the molecular formula, that is C4H6Brn, that is combining the molecular ion peak with the isotopic pattern, and the loss of the bromine, and the molecular formula can be confirmed as a C4H6Brn consistent with 4-bromo-butanediol. Now we'll move to the next slide, which one? This one. So, discuss this. Yeah, we have already discussed this. So we'll move to the next slide, which is this one. Yeah. So this is 13 carbon NMR spectrum of the unknown compound. So we will discuss about this, that how we'll do it. So the first we have to see the number of the unique carbon signals. For distance, carbon signals indicate 4 unique carbon environmental and in the molecules. Nitrate carbon C triple bond N signals, a signal in the range of 110 to 130 ppm, confirm the presence of the nitrile group. And the third one is the carbon adjacent of the bromine signal. A signal in the range of 20 to 40 ppm indicates the carbon bonded to the bromine atoms. And the fourth is the alkyl carbon, that is CH2 group signals. Signals in the range of the 10 to 30 ppm correspondence to the remaining methyl group in the carbon chain. And the last is the absence of the DEPT 135 signal for the nitrile carbon. The nitrile carbon will not appear in the DEPT 135 spectrum, confirming it has no attached proton. Next, the same as we discussed about this one, we'll discuss about this one hydrogen NMR spectrum of the unknown compound. So in this, what will happen to check the presence of three distinct proton environment, the first spectrum will show three distinct sets of proton due to the presence of the three different hydrogen environments. And the second is the chemical shift of the terminal CH3 group, which is methyl group. Signal around zero point 0.9 ppm indicate the presence of the terminal methyl group, which is a typically chemical shift for the terminal methyl proton. Then the third is the chemical shift of CH2 group, which is a signal around like 1.2 to 1.5 ppm indicate the presence of the methyl proton. This region confirms the CH2 group in the butane chain. And the fourth one is the chemical shift of the CH2 and a group adjacent to nitrile. A signal around 2.4 to 2.7 ppm confirm the presence of the CH2 group adjacent to the nitrile group, which appear downfield due to the electron withdrawing nitrile group. And the fifth one is the integration and the splitting patterns. Integration shows the ratio of the protons. The integration ratio should match 3 ratio 2 ratio 2 for the CH2 adjacent to Br and CH2 adjacent to the nitrile group. Splitting pattern will follow the n plus 1 rule for the neighboring protons such as the triplets and multiplets. The next slide will discuss about the structural formula of the unknown compound of the molecules formula, which is C4H6 and NBr. So in this, we can see the chemical formula. The molecular formula is C4H6BRN, which indicate it is a bromo substitute nitrile with the 4 carbon chain. Functional group bromine atom located on the 4th carbon. This is a halogen and substituent and the nitrile group. Carbon triple bond to the nitrogen found on the 1st carbon of the chain. The physical properties like usually are colorless to light yellow, liquid or solid. And the boiling point approximately 131 degree, or we can say 268 Fahrenheit, which is relatively high due to the presence of the nitrate. So we all discussed about the basic structures, like the different structures, how we can elucidating the unknown organic compounds. Thank you.